So hi everyone. So I'm Kumar. Welcome to Java's full stack course. So let me introduce myself first. I am currently working as senior software engineer at Amazon and I have total of 6 years of experience. I have did aerospace at IIT Bombay. Okay. So firstly, what I will do is firstly we'll take some poll. There will be two questions in that poll. Please participate in that poll and like around 30 seconds to answer that poll. So you can scan this QR code or you go to slido.com in your mobile and enter the event code 3209491 and you will be able to participate in the this poll. So let's see the results here. Once you do this, we will be able to see how many people have participated in this. If you are facing any difficulty, please speak up. One of you has done. Can I expect few more? Just scan the QR code and go to slido.com and enter this code. This is just to take like uh, how many people know what. So I want to just know like the audience so that I can cater them better. Okay, I'll close this in another 10 seconds if any others are participating. Anyone?
If it's sharing in a YouTube later, then also we can able to get to know it will close usually.
Yeah, I will do after once everyone join also. So this
Mhm.
is just to take for today's class.
Okay, okay. Yeah,
Yeah,
great.
so after these free classes, again I will take so that I'll get full view of
Mhm. Yeah,
students.
sure, sure, sure. No, no, no.
Okay, I will stop this.
Okay.
Uh, Mostly it's mid-level and fresher. Anyone still attempting to participate in this?
Some people
Oh,
join now, it seems. Maybe. Guys, who are joined now, right? You can try to scan this QR code. Maybe we can get to know like what's your previous experience and all, just for a reference.
yeah. Or you can go to slido.com and enter this code 3209491. So for now, I see like it's mid-level and fresher. So, uh, so our class will be catering to both mid-level, fresher, everything, like even professional also. But in initial lecture, professionals may feel that they already know few of the concepts. So they'll have to be patient and go through the course because like for freshers, I'll have to teach from basics, right? So that will be there. But trust me, even professional will learn lot of new things in this course. It's not like everyone knows everything. So that will be there. Okay, I'll just close this for now. I got another response. Okay, nice. Okay, there will be another one question. I'll take that and then I'll move on because it's getting little late. Oh, there is. Hmm. Here, fresher means I meant at least they have no some knowledge ki what is going on and like that. No experience means you don't have anything. Okay, I'll just stop the interaction. Now I just want to know why do you want to take this course? So like what is your purpose? You can write one word or two, three words. Where so class will see again in the same link. You will see this. Why do you want to take this course? Just let's finish this fast so that please participate. You can write one or two words. Need not be a big sentence or something like that. It can be like you want to learn new things. It can be like for placement. It can be like for uh, new skills. Okay. Yeah, to get a job, nice. To be professional, full stack knowledge. Okay. I am in mid-level in Java full stack. I need to complete professional. Nice. To make my resume better. Okay. Placement. Nice. Okay. I just got a overview. If someone is still participating to get a job, nice. Okay. You can still type. We will see in another 10, 15, another 1 minute. Till then, I'll just start the course. Okay. Let me start. Let's get set and learn. Today's our first lecture. We will be looking into introduction to programming languages and introduction to Java. So we'll see both. One thing, class. I want this class to be interactive. You are encouraged to speak when you have doubts or when you have any like you are any concept that is there that you are not understanding, any term that I used or any word that I used that you don't know. So I think English is fine for everyone, right? Here, say yes or no.
Yes, sir.
Okay. ठीक है, I heard one. ठीक है. So I don't want this to be boring, where I will be the one who is speaking. I would encourage you to ask questions. You can ask like questions that everyone can have doubt on, that you have doubt on. Anything you can ask. Okay, let's start. So what we'll see introduction to programming languages. We'll see what are programming paradigms. We'll see comparison of different types of languages. So we'll see like based on various features how we can classify languages. We'll see introduction of Java. We'll see some brief history of Java, how Java was developed, what had went into. We'll see comparison of Java with other languages, and we'll conclude today's class. Okay. I'll just go back to that poll. If anyone else has answered, I am fresher, want to start my developer journey. Okay, nice. Okay, let's start with this meme. So how many of you think ChatGPT is a programming language? No, right? So like please answer whenever I ask few questions, or else in the next class I'll start taking names and getting answers. Okay. So we know that ChatGPT is not a programming language. It's just a tool to help you learn. You can't ask it to build a app, Java app for you. You must do that for yourself, right? You will have to learn Java and do it. So it's not like ChatGPT is there, I can do anything. That won't be there. So that was the purpose of this meet. So let's start. What is a programming language? Anyone in the class, can you answer? Can you give example of one or two programming languages? Anyone? So I will just see few participants. Vamsi, can you tell me one example of programming language? Any one example. Anyone can unmute and tell. So any programming language you have heard of, some name. Don't say Java. Java is what we are going to teach. Guys, anyone? Someone has written C. Okay, nice. Okay. So I'll see. I will define what is a programming language. A programming language is a formal language that specifies set of instructions for a computer to perform set of tasks. So this is the definition. So generally, how people communicate through a language, right? So it might be English or Hindi, any language. So if you want to understand me, I'm speaking in English. If I want to understand you, you can speak in language that I understand. Okay. So now let's say you want computer to understand you and do your task. You have to specify, tell computer in a language, right, similar to language we communicate with. And one more thing, in English, we say I am Kumar, right? We cannot say I is Kumar, I are Kumar like that. We cannot say, right? So English has a grammar. Similar to that, even programming languages have grammar. You have some syntax or you have some grammar, and you have to specify in that grammar only. That's why programming language is a formal language that specifies set of instructions. This is that instruction is that grammar part for a computer. So it's not for a human to perform something. It's for a computer. That language is for a computer. And what that computer will do, it will perform set of tasks. Okay. Anyone has any doubt on programming language? Understood the definition? Okay, I think it's clear. So some examples, Java. So that is what we are going to learn in this course. C++, Python, Go, JavaScript. So these are few examples. It's not a list of all programming languages. There are a lot of programming languages in this world. So it's hard to learn everything. But these are like popular languages. Let's move ahead. So why are this language important? Can anyone tell one reason why programming languages were made and why are these languages important? Anyone? So
To communicate with.
I want this
Hello.
to be interactive. Okay. So please communicate. If you speak only, I know ki what you understand, how you, what and all you know. So that is where I will understand, right? Or else I'll just take few names. Arvind, or Suman. Anyone can speak up. Why are these programming languages made? Any reason you think? Why are these languages important?
Hello.
Yeah, speak. Yeah.
So the machines can understand only binary digits like zeros and ones, but we
Okay.
can't. All of them can't able to understand that sequence. So the programming
Okay.
languages for made we can able to easily understood, and we can give our input like in programming language, and that programming language converted into machine language, and the machine will understand it.
Hey, yeah, that's a very good answer. Yeah, nice. So we'll see. That was the answer for my question, which I asked. Why are these programming languages made? That's very good answer. We'll see why are this language important as well. We'll see for three, four reasons. So computers, communication with computer. So what programming language enable us to communicate with computer? So lot of difficult tasks we can do easily with computers. Okay. Next is efficiency and automation. So what is automation? Meaning you can automate your task. You don't have to do the task repeatedly. So let's say I want to grade students in the class, and I just know the marks. What I will do, I will write a program, and I'll just enter marks of each student. The program will grade student that this student is rank number one, this student is rank number 10, this student's uh, percentile is this student's this is that. So that program is enabling it, helping me to do some automation. So once I have to write that program once, it will help me throughout the year like that. Next is software development. This is the most important part of programming languages. So many companies are built around software apps right now. So we daily use, like in our day-to-day use, lot of apps we use. Even Chrome is an app. The web browser you are using, that is an app. Mobile apps, you play games, video games, all of those apps, those are built using programming languages. Nowadays, we cannot imagine life without programming language. Next, this is this is the recent era. So like in last 10 years, data analysis and insights have become like trend. Okay? So even for that, programming languages are essential because it helps us analyze vast amount of data, and you can just like aggregate your data, find some insights, and run business. So, okay? So these are few reasons why programming languages are important. Now, what we'll see programming paradigms. So, what is meaning of paradigm? Can anyone tell? Like any info, you can write in chat. If uh, you can just type in chat, I'll look into that. What do you think? What is a paradigm? Programming paradigm. Anyone has heard of this term? Programming paradigms. Okay. So I'll start it. Mean so programming paradigm. What does it mean? So these are like kind of approach. So paradigm here means an approach you can use to program. So you are given a task to program. What you can do, you can do it in a one way. So that way can be called A. So you can do it in a way A, and you can do it in another way also. Same task that can be called as B. So even if let's say if I give the class a task to perform code, every one of you will come with different code. It will not be that everyone will write the same code. So programming paradigm is like the style or the approach you use to program. Okay, it's style. So what people have done when they are making programming languages, let's say Java inventor or Python inventor, so they will think that aha, this is the programming paradigm people should follow when they want to use this program, this code, this program, this language. Okay, so they will build their whole programming language around that paradigm. Okay, so we will understand this in a few lectures in detail. So you will get to know different programming paradigms. So you will understand it much more clearly. But paradigm means here of different style or approach of programming languages. I think if there is any doubt, please unmute yourself. If you're not understanding, let me know. Okay. So now, what there are like lot of languages. So there are a lot of programming paradigms. So people have classified majority of programming paradigms into imperative and declarative. There might be other classification. So what I have listed here in the slide is the important parts. So there is a imperative programming and there is a declarative programming. So these are two different styles of programming. Most of the programming styles are classified into these two. In imperative, there are like uh, tens of programming paradigms, but we'll see major important to procedural programming and OOPS programming. OOPS is like object-oriented programming system, something like that. And next is in declarative, we'll see two. There are a lot more, but these are the important ones: functional programming and domain-specific languages. So programming paradigms is what? It's a style of programming. So how you program to perform a task. Task is same, but how you do it. That is the important. That style is called uh, paradigm. Let's move on. We are getting late actually. Let's see imperative versus declarative. First, we'll understand definition of imperative and definition of declarative, and we'll see some analogy and example. I think I'll remove that chat bar. So definition of imperative. So when you program, right, you will have a task and you will have a result. So that program should give this result. So you will have some expectation of the result. So in imperative programming, you will tell how a program should achieve that result, and you will also specify exact steps to achieve it. Okay? But in declarative, it's not like that. You will just tell the program you have to achieve this. You don't have to provide lot of steps ki do like this, like this, like this, like this. You just have to perform like higher level steps. ki you can do like this, you do like this, but you will not tell ki each and every word or line ki you will have to do something like that. Let's say example, this is an analogy. So you you want to cook a food or you want to eat food. Let's say you want to eat a burger. Okay? What you will do, you will there are two options. You can take a recipe and make a burger and eat it. So in the recipe, you will have step by step instructions on how to cook. Maybe you'll have very detailed instructions. Bake your bun like this, or fry your that patty, burger patty in oil like this. So this step by step instructions to cook a food. This is imperative programming. So everything you will see step by step. Next, in declarative, you don't know how the task will be done. You don't care. You will just tell, bring me burger in restaurant. You will get the burger, you are eating food. And in the end goal was eating a burger. So how you got the burger? That is the difference in imperative and declarative. Okay, some examples. C, Java, Python. So in all this, you will have to write exact step by step what you want to do, everything you have to do. In these languages, SQL, HTML, CSS, it's like a declarative. You will tell program you should achieve this. Let's say if people are familiar with SQL, you will say I want this data from database. That SQL engine will determine how to get the data and return the output. You don't have to tell ki just put the data in this variable or do like this and then do like this and then get the data. That is not required. So this is the difference, imperative and declarative. Anyone is confused or didn't understand? Am I too fast? Okay, I'll continue. Now we'll see each and four programming paradigms we have seen in this class, right? All these things we will see. Okay. First, we'll start with procedural programming. So, what is procedural programming? In procedural programming, we break down programs into series of steps, step by step instruction. So, example C. So, what you will do, you will just program. Let's say you want to calculate whether you want to check if a number is odd or even. Okay. What you will do, you will divide by 2 and check the remainder. Okay. First step will be divide by 2. Then next step will be check the remainder. If remainder is 1, that means it's odd. If remainder is 0, that means it's even. Okay. These are kind of steps. You break down your program into steps and you can just execute those steps. This is procedural programming. There's a procedure and you follow the procedure and get your task done. So example, analogy of baking a cake. Let's say we want to bake a cake. You will have recipe. You will have instructions like this. Preheat your oven to 175 something. Mix ingredients and create batter. Grease cake pan and pour batter. Bake for 30-35 minutes. Okay. So these are like defined instructions. So in procedural programming, you just break down your program into series of step-by-step instructions. Okay. Next, we'll see object-oriented programming. In object-oriented programming, you don't do step by step. What you do, you define objects. So objects here can be chef. Here it can be microwave. Here it can be a mixer. So these are objects, and you can define what that object can do. So this microwave can preheat. This microwave can bake. So for preheating, you can specify which temperature you want to preheat. You can specify for baking how much time you want to bake for. And this mixer can mix. You can specify list of ingredients to mix. It will mix. Uh, this chef will get all the ingredients. The chef will check whether the cake is baked or not. Okay. So these are like objects. The task was same. Here you just took the recipe, followed the instruction, and completed the things. But here what you do, here you will create objects. So these are objects, and you will create the functions that what each object can perform. Then now you want to bake a cake. What you will do? You will define these objects. You will bring microwave. You will bring mixer. You will bring a chef. Okay, and you will ask microwave to preheat. You will ask chef to get ingredients. You will ask chef to put those ingredients in the mixer. You will ask mixer to mix, and then you will ask the chef to put the batter from mixer to the microwave, and then you will ask microwave to bake, and then you will ask chef to check if it is baked or not. So this is different style. You're doing up the same thing, but just different in different style. So lot of programming languages support OOPS. Okay, it's in short form. It's called OOPS, but it's object oriented programming. Everything about objects. Okay. Anyone has any doubts on this? Okay, I'll proceed. Next is functional programming. So these two are declarative, imperative programming. These two, procedural and OOPS. You will have to specify each and every functions. You will have to specify each and every instructions, and then you will have to do it. You cannot expect just you can tell result and do it. Okay. But this is functional programming. This is declarative programming. So what it does, it treats your program as different mathematical functions. So you can write mathematical functions, and for each function, if you give some input, it will give that output. So if you give same input, it will always give same output. So that is what that is what means functions are pure and avoid side effects. So some languages in which you can use functional programming is Haskell and Scala. So similar to that, what we have seen in OOPS and procedural, we'll see like this is also baking a cake in functional programming, but you're baking a cake in that what you will call in machines will be there, right? Industry pipeline, like the milk packet is made like that. Some pipeline is there. Automatically, that bowl will come here. Okay, and ingredients will be poured using machine. So you're just telling bake a cake to that machine. You are not doing anything. That what machine will do? Machine will bring this roller will bring the ball, and some machine will pour all the ingredients. So it might be flour, it might be water, and whatever it is. And then it will move to the next stage. That bowl will come here. There will be a mixer above that will mix those ingredients and form the batter. And then using this treadmill, the bowl will go to microwave, and automatically microwave will get switched on, and then it will be baked, and the cake will come out. Okay. So there are like these are mathematical functions. So pour ingredients. Always the machine here will always pour those ingredients in the same quantity. So whatever, if you give same input, bake a cake, it will always pour those ingredients only. So this pour ingredient is a function. This mix ingredient is a function. This bake in oven is a function. Now cake is ready. So it is just the style. In the end, in all the three programming style we have seen, these are the most important three programming style. In all the three, the end result was baking a cake. But how you did it, that was the important part of paradigm. Why are you learning these paradigms? Because when you learn any language, right, you know how that language is built, how people code in that language. So if you know programming paradigms, you will easily understand how you have to code in that language, and it will be easy for you. And it's not like one more thing, it's not like one programming language you can do only one thing. So it's not like in Python you have to only use oops concept. You can use functional programming also. It is just a style. Okay? But some languages don't support OOPS. Some languages do not support functional programming. So it can be like that. Okay? So OOPS is Java and Python. So mostly our whole course will revolve around object-oriented programming. So these are the three styles. And one more is domain-specific languages. This is uh, not a this is also a style of programming, but this is just specific to the domain it caters to. Okay? It will solve, these languages will solve problems in that specific domain or area of application. It's not like general language. Okay? So SQL is for databases, HTML is for web page content. So you are seeing this application that might have been built using some HTML. You are seeing some web browser, some web page you are using that is built using web page content. And CSS for styling, colors, all those things. How the border should look, where it should be, all those things. Okay, these are domain specific languages. These are not general languages to code, but this is also a different style. And these are mostly declarative because the SQL example I gave, you don't have to tell how to perform. And let's say you want to find max of a column in database, let's say. So you just run that SQL query. If people are not aware of SQL, it's fine. You can take HTML example. People might have heard of HTML. It's for web page. So you just tell that these things have to be loaded. You don't tell how it should be loaded in browser. It's not the how part. It's just what you want, achieve part. So this is the declarative part. So what we have seen four programming paradigms. There are a lot more, but these are the most important. That's why I've shown only four. And for three of these, we have seen an example of baking a cake. So the end result was baking a cake, but how you achieved it was different in each of these programming style. Okay. Any doubts in programming paradigms? Please speak up. Any doubts you can write in chat. Okay, let's move on. Now what we will do, we will compare like languages across features. Okay. So first is high versus low level languages. Okay, let's start. Give me a minute. That's fine. Okay. So how is it? Computer understands in the class someone told, right? Computers understand just binary. Okay. So there is a hardware. This hardware will perform your task. But computer just understand binary, which is machine code. But it's not easy for humans to understand. You can't tell computer 010001010101 because you don't understand that easily. So what they have built? They have built some assembly languages. Initially, all computers was using assembly languages. Okay. So everyone used to code in assembly languages, which is very difficult. We'll see an example. You will understand why. And then what people did, they have built some abstractions over it. I'll define abstractions. And they have built high level languages. So what are high level languages and what are low level languages? So low level languages are this, assembly languages and machine code. High level languages are other languages, which we see Java, C, Python. So we'll see examples. So high level languages are easy for humans to understand. Okay. Why they have built high level languages? Because so that we can understand and code in it. We can't remember 010101 thing, right? It's very difficult. And low level languages are languages that's easy for computers to understand. hard for human to understand and code. So what is abstraction here? Abstraction here means you do the more the abstraction, higher languages have higher abstraction. That means you don't care about how computer is getting zeros and one. Okay? How that computer has converted your code, which is looking like an English language, to zeros and one. That you don't care. You just care about the instructions you are given. That means what the makers of Java, Python has done, they have provided some abstraction on top of those zeros on instruction, so that when you write your code in the grammar, they have specified. So every language has grammar, we have seen, right? So that mostly that grammar will be like a English language only. It will not be some foreign zeros and ones or some other language. So in all high level languages, it will look like if this, do this, do that, like that. It will be like that. It will be in English. So this understanding of languages like English, it's possible because makers of languages like Python maker, let's say I have made some other languages, some language named X. So makers of languages provides higher abstraction that uh, so they have hidden you. So you don't know, like you don't know how your code is converted to zeros and ones. They have provided that abstraction. They have hidden from you that this will be converted to machine code like this. Okay? You don't know that they have provided that abstraction. Okay? So abstraction means you don't know how computer gets the binary instruction. You just know the programming language. Okay? So this is the definition, and it's like this. So if you go, so it's like this. Sorry, if you go from top to bottom, the abstraction will reduce. Okay? And you'll start, it will be difficult for you to understand. Okay? So this is high versus low language. Now we'll see some differences between them. Okay? So readability part we have already seen. High level languages are easier for humans. Low level languages are harder for humans to understand. Why? Because high level languages have more abstraction. So the more it is abstracted, the more it's easy to understand. So in future, it's possible that you just write in English, just type the English thing, or just speak in English. Your program can be executed. Nowadays, it's getting possible, right? Because of ChatGPT or something. Okay? But that the accuracy is the problem in English language. But that's why we have grammar for programming languages. But I'm telling, the more the abstraction, the easier for humans to understand. Similarly, low level languages, it's the abstraction is very less. Next, performance. High level languages are slower and low level languages are faster. Why? Because in high level language, you still have to convert that language into zeros and ones. But in low level language, it's already converted. Like it's very easy to convert, or it's already converted part. So machine code or assembly language, it's almost converted, and it will execute very fast. But in this, there will be some time taken to convert into machine code. So examples of high level languages, Python, C++, because they, if even in Java is also high level language. So they provide higher abstraction. They'll provide a lot of different things to do something. You don't have to worry about how it's executed in computers. Low level languages, assembly and machine code, which we have just seen. Machine code is like zeros and ones. So one code example we'll see. You just have to add two numbers, A and B. What you will do, int sum is equal to A plus B. Okay? But in assembly language, it looks like this. Move A to this register, add B to this register, then move sum to this register, move EX to this sum register, like that, something like that. So it's difficult for you, right? Even if you don't understand this, like even if you understand this, it's difficult for you to think and write. You can make a lot of mistakes. But here it's very simple. You just have to do a plus b sum. Okay, it's that simple. So this will get converted to this, and then this will get converted to zeros and ones, which will be executed. But because the makers of languages have provided this higher abstraction, it's easier for you to understand. Okay, that is difference between high versus low level languages. Okay, any doubts? I'll just see the chat if anyone has messaged anything. Anyone is feeling I'm fast. Anyone is feeling. Please speak up. Any doubts? Okay, I'll proceed. Let's see now compiled versus interpreted. So what we have seen, we have classified languages based on high versus low. So low level languages are assembly and machine code. High level languages are Java, C++, Python, all this. Now we are classifying languages based on compilation. So whether that language is compiled language or interpreted language. So what is compilation? Anyone? Anyone has heard this term compilation? You can type in chat. Okay. Please speak up. Yeah. Compilation is related to syntax error, but yeah. So what is compilation? Compilation means your code, whatever you have written, is converted to machine code. That is compilation. Okay? It's like a translation. Every code you write will be converted to machine code because that is what machine understands. Okay? So in some languages, translation happens even before execution. In some languages, it happens after execution. So that is what in compiled languages, you compile the code and then you execute it. So there is two steps. You compile, you can execute it 10 days later. But in interpreted languages, you always, it's just you execute. There is no compilation step at all. Okay. So in compiled languages, you compile and then execute. In interpreted languages, you execute. There is one step. Next is speed. Compiled languages are faster. Interpreted languages are slower. Okay. So sorry, I told definition of compiled languages. I forgot to tell definition of interpretation. So in compiled languages, we compile and get the machine code and we'll execute that machine code. In interpreted languages, it doesn't work like that. How interpreters interpret your code is they will go line by line. Each line they will interpret in that second only. Whenever you are executing that code, it will check you have written if, so that they will convert to machine code, send the instruction, and then it will read next line. It will convert that to machine code, send the instruction. So that is how interpreters work. Okay. So compiled languages, the translation to machine code happens before execution. In interpreted languages, it happens during execution. Okay. Performance, speed, compiled languages are faster. Can anyone tell why? Ideally, interpreted languages should be faster, right? Because it's one step, it's two step. Okay, I'll just tell. Because in compiled languages, you are converting the whole code to machine code. So machines now understand the instruction faster and it will execute the code faster. In interpreted languages, it has to go through line by line. First, change that to machine code. Now, machine will remember that line instruction and then it will get the next instruction and it will take some time. That's why compiled languages are faster. Interpreted languages are slower. In debugging part, compiled languages, errors are caught during the first step. So when you're compiling that time itself, your errors are caught. Most of the errors, not all. That is what someone has mentioned, syntax errors. But in interpreted languages, all errors are caught once you run the program only. So what is the benefit of compiled languages? Before even running the program, so the program might take some resources, right, to run. Before you're running the program, you will find most of the errors in your code, syntax errors, all those things you'll find. Some errors it's not possible to find, but yeah. So some examples of compiled languages: C, C++, and Go. Interpreted languages: Bash and JavaScript. Okay. Any doubts? Yeah, we'll move to the next slide. Next is static versus dynamically typed. So if there is any term or any word, programming term that you are not understanding, you can message me after the class or you can ask in the class. Okay. Eventually, after few lectures, you will understand everything because we will go word by word, detail by detail. So I might tell execution. Execution is a word I used, but people might not understand that execution word. We will see the execution, we will understand that word by word in future lecture for sure. People might not understand compilation now, but when they see it live, compiling, we are compiling our Java code, then you will understand that very clearly. So some part might not be understandable now, but even if you're not understanding, let me know. I will simplify it to you. I will give some analogy. I have prepared like lot of analogies for difficult things for you to understand. Okay. Now let's start with static versus dynamically typed. So we have classified languages based on high versus low, how the abstraction part. We have classified languages based on how it is executed, like compilation, compiled versus interpreted. Now we'll classify based on typing. Okay. So there are statically typed languages, there are dynamically typed. So what is typing? First we will understand that. So in every language, there is a concept called data type. Okay. So there is a concept called data type and variables. We will see this in our future lecture for sure. But brief overview, a variable is like a box. Okay. You want to store some data, you can store it in that box. Okay. That is a variable. But that box can be of different sizes. Okay. So that you can store only these kind of items in this box like that. So that is specified by data types. For example, you can store in an integer, any integer variable, you can store only integers. You cannot put 0.1. Okay. You can just put integers 1, 2, 3 like that. So let's say this is an example. So this is a variable A. This is an data type integer. So what you are storing 5. This is allowed. So typing here means you specify types of variable. Statically typed means you have to specify. Dynamically typed, compilers will find. You don't have to specify. If you put a equals 5, compilers will think you have put 5. That means a is an integer variable. Compiler or interpreter, whatever it is. So in statically typed languages, type declaration you have to do before execution. But in dynamically typed, it happens during execution. So in during execution, it will see you have put 5 into that variable. That means it's an integer. You have put 0.1. That means it's float like that. Next, type checking. When will computer check the types? In statically typed, at compile time only it will check, not during execution. So that's why you'll find some syntax error. All those things you can catch. So type checking happens at compile time in statically typed languages. In dynamically typed, it happens at runtime. So when you're executing the code. So runtime is like execution of the code. Compilation is just converting your code to machine code. It will not execute the code. So these two terms, compilation, runtime, You will hear from me a lot. So we'll see even definitions. Okay. Performance. Statically typed perform better. Dynamically typed are slower. Why? In statically typed, you're telling your computer that this is the type I'm expecting. But in dynamically typed, computer has to get the data and then determine that this is the type. So that's why it will take one extra step to determine that. So that's why it's little slower. But in statically typed, it's better. Some examples. In statically typed C, C++, Java, these are statically typed. You have to specify int, float, double to declare any variable. Dynamically typed, you languages like Python, JavaScript, you don't have to. Okay. So we have classified languages. We have seen programming paradigms. We have seen what is programming language. Okay. Now let's start introduction to Java. So this is what you are here for, learning Java. So why did we go through this definition, right? So before you learn any programming languages, you must know what other programming languages exist. You must know how people code in programming languages. You must know what are the types of programming languages, how they are classified. So all this information you should know. Then if you learn language, you can relate, yeah, Java is OOPS paradigm, Java is compiled language, Java is high level language, all these things you can relate. Okay. Now let's see what is Java. Okay. Java is also a programming language. So we have defined programming language already. Sorry. So Java is a programming language. What it helps? It helps programmer write once and run anywhere. We will see this in tomorrow's class. Write once, run anywhere part. So that's called Vora. So Java is a programming language. It helps you to program anything, take your task, build an application. Lot of things it does, and it's called Vora. Vora means write once, run anywhere. We'll see the explanation of this tomorrow. Okay. Now let's see some brief history of Java. Okay. So Java was developed by James Gosling at Sun Microsystem. So there was a company called Sun Microsystem. James Gosling thought, what did he think? That most of the languages are dependent on OS we run. I want to make a language that's platform independent. That's Vora. I want to make a language that you can write anywhere, run anywhere. So then he started development of Java. Okay. So in 1991, development of Java begins at Sun Microsystem as Oak. Okay. So initially the language was named as Oak. Later they changed it to Java because Oak was already trademarked. In 1995, they have released an official version of Java. Okay. In 2006, people thought that it's widely used. Let's open source it. So Java is released as open source language. 2010, Oracle thought कि Java can be a next big thing. Java can become very huge. Let's buy Sun Microsystem. So they acquired Sun Microsystem. They started owning Java. Okay. 2014, they have released Java 8 version, which is widely used now, even now. Java 8. So in the current market, like it's 10 years, 2014 to 2024, we are at Java 22. It was released on 19th May. In I think this September, we'll get another release also. Okay. Oracle, September or October. Oracle has been releasing two versions every year. That's very remarkable. So that they are keeping Java updated. You cannot think Java is outdated when using Java 8. Java is getting updated based on new technologies, lot of performance, bug fixes, everything goes on. Okay, so this is a brief history. It started in 1991 and is still used. It's highly demanding language. Okay. Now let's see, why do you want to learn? Why do you want to learn Java? You might have seen this in demo, might have seen these slides, but this is like proper class, so we'll go through this again. So if you see PyPL statistics, Java is second in top programming languages, second. So why Java? Why do you want to learn this? Because of its popularity and demand. So Java is widely used across very large enterprises, medium enterprises, startups. It is used widely used language. Next is it's easy to learn. Its syntax is similar to C, C++, which taught in most of the engineering colleges. Its syntax is easy to remember, easy to follow. And Java community support is also huge. If you're stuck at anything, you can just put it on community support and you will get the help. Or you can just type it on Google. You will find someone else has faced that issue and you can easily troubleshoot. For newcomers, it's very easy to learn. That's why that is one reason why you have to learn Java because it's easy to remember. Next is versatility. If you learn Java, you have many career options open. You can do web development, you can do Android development, you can do full stack, you can do big data, you can do machine learning. So in big data machine learning also, uh, people use Spark. So nowadays people have you are started using PySpark, but Spark provides Java API also. Okay, people code machine learning ML lib provided by Spark that is also can be coded in Java. So that it's versatile. Lot of use cases are there for Java. Okay. Next is its class cross-platform support. So you can that's what we have seen, right? You can write anywhere and run anywhere. Okay. So we'll see this in detail tomorrow, cross-platform support. But you can run on multiple operating system, even on mobile. You just have to write once. Okay, for other programming languages, you might have to maybe uh, write in, like, let's say you're using Mac OS, you wrote the code in Mac OS, but it will not run in Linux. We'll see this in detail tomorrow. Okay. Next, salary. So you, whenever you do take a job or something, you will see salary prospect, right? So Java developers are highly paid in the industry because of its demand. Lot of enterprises like Netflix, tech giants, Airbnb, all use Java to build their application. So you'll see a lot of enterprise software. Let's say, have you heard of Tally? Maybe that might also be built in Java. Tableau, you never know. Okay? This is why you want to learn Java. Okay? So what we have seen till now, we have seen what is programming language. We have seen styles of programming languages. We have classified them also. And we have seen some introduction of Java. Okay? Now let's compare Java with other languages. Before that, can anyone tell why do you want to learn Java? Just we'll go one round. You can put it on chat also. Just tell me why do you want to learn Java? You can just write salary. You can just write just new skill I have to learn for placement, for job, anything you can write. I think we have already seen why do you want to take this course, but okay. Think people have left and joined back. It's okay. I think I will proceed then. So now let's compare Java with two other languages. Okay, Java and C++. First, Java with C++. So how many of you have used C++? Just type yes or no in chat if you have used. Okay. So if people have used C++, they might know pointer. Okay. So it's a kind of storing memory address. It's like uh, the variable we have seen, right? Box. So it's to store the data. What is a variable? It's a kind of a box to store the data. Where that box will be placed, that is a memory address. So I am placing the box in my cupboard shelf number 5, like that. So that's a memory address, cupboard shelf 5. So another variable can store key. My box is placed in shelf number 5. So that that another box is pointing to this box. That's called pointers. So C++ supports pointer. In C++ you can store key. Where is my box? That you can store in another variable. In Java you cannot store like that. Okay. So why why in Java we can't use pointers? Because in C++ if you have used pointers, you see it makes life very difficult. It's very hard to understand the programs. Okay. Java people have simplified it. You cannot use pointer. Okay. We might be able to achieve the same task in Java in some other way, but it's not that in C++ we can do some magic because of pointers. But yes, so this is one difference. You cannot use pointer in Java. It's not supported. In C++ you can use. So that means even if you compare C++ and Java, Java is giving more abstraction. In C++, it was giving some flexibility to access memory addresses. Okay? But in Java, you cannot. Next is portability, which we have seen. I have been talking about this in last 3 slides. Java is platform independent. You can write anywhere, run anywhere like that. We'll see that tomorrow in detail. You will understand why. Why did they do that? You will understand that. How also you'll understand how Java is platform independent. That is also you'll understand. C++, C++ is platform dependent. That means you take C++ code, build it on Mac, compile it, but you cannot run it on Linux. You will have to compile there again. Okay. Next is programming feature. So in Java, so there is something called functions. You will see what is functions and all. So functions here means you in Python also there are functions, right? Add is a function like that. See in Max also there are functions, right? Add or maybe sum is a operator or function. Okay. So even in programming there is a function. Function here means you define a function and you can use that. It's like we have seen in functional programming, you define power ingredients. It's like that machine, and you made that machine. It will pour ingredients for you. Like that, you can define functions in languages and functions and variables. So in Java, functions and variables cannot be outside class. So we'll see what is a class also. We'll see that. But in C++, they can be outside class. So these are small differences between different languages. So if you want to create a language, you will have to decide on a lot of things, how this will be done, how this will be done. So C++ people have told that you can declare functions and variables outside class. I don't care. But in Java, they have defined no. Everything will be built around class. Everything will be built around objects. So we want Java to be object-oriented programming like that. Okay? Next is compilation, which we have seen compiled versus interpreted language. What was compilation? Conversion of code into machine code. Okay. So if you speak in terms of compilation, Java is a compiled and interpreted. So it's not just compiled. So in Java, directly your code will not be converted to machine code. In C++, it will be. In C++, you compile your C++ code, you will get machine code. Okay? You will get machine code, just you can execute it. But in Java, you will see this tomorrow. You will see compile. You will compile and get some bytecode, and then that bytecode is interpreted by Java interpreter, and then that will be converted to machine code line by line, something like that. Okay. So see, differences are there in every language. If you take, the differences will be there. Next is thread support. This is like multi-threading. You have threads in computer, right? So Java has built-in thread support, but C++ doesn't have. These are few differences. You can find more differences if you are interested in finding differences. Okay. Now let's move with the most important part people want to know: Java versus Python. Okay. I haven't written all the differences. Okay. We'll see one code length. Okay. So since Java, you will have to define types. It's more easy to read. Even Python is more easy to read, but its syntax is like that. Its syntax is more verbose. So Java has longer lines of code. So if you're doing a task in Python, you can do 3 to 4 times shorter. But in Java, the number of lines are longer. Okay. But that makes Java code readable. Even Python codes are readable, but sometimes it's difficult to understand because people would have done it with very shorter syntax. You can do it in very, very short syntax, single task. So it's very hard to understand. But Java code will be very easily readable. You don't have to think a lot to code in Java. But in Python, you might, if you want to do shorter code, you might have to think. Okay. Next is ease of typing. We have just seen what is typing. Typing is whether you have to specify type or not, statically typed and dynamically typed. Java is strongly typed. That means you have to define type. Without type, it will give compilation error. But Python, you don't have to define types. Okay, you can just put a equals 5. We have seen that example. You can just put a equals 5. But in Java, you have to define types. So performance, so we have seen, right, statically typed languages perform better. So Java is much faster. Python will be slower. Okay, so that's why in enterprises, full backend development, since the speed is very important, latency is very important, people still prefer Java. Okay. Next is syntax. So Java uses semicolon, curly braces for syntax, but Python just uses indentation. Okay. There are a lot more other differences, but we have seen few. Let me check the time. What's happening? Okay, it's 8:15. We have 15 minutes. Okay. Now I'll just see how many people are still there. Okay, people are still there. So let's conclude today's class. Can anyone tell me what is programming language? We'll revise because it's difficult for everyone to remember everything, right? I will explain in brief everything, and then we'll see some exercise for today. So you can just go home, think about the exercise, and come to tomorrow's class. We will discuss on that part also as well. Okay. So what is a programming language? A programming language is a formal language. Using that, you can give some specific set of instructions to computer to perform some task. Okay, that is the definition. So any programming language you take, that will do some task. How it will do? Using computers. You can give some task to computer. Okay. There are different programming paradigms. So programming paradigms are just a style. You can it's the style of programming. The task remains same, but you can have different style to program it. Different style to do it. We have seen one example, right? We have seen cake, baking a cake. In procedural, you just follow the recipe. In object-oriented programming, you define objects like chef, microwave, or mixer, and you build functions around that. And similarly, in functional, it's higher order functions you have built, and you can just call those functions and execute your code to get some output. Okay. these are different styles of programming. There was one domain specific languages also. That's like specific to domain, like HTML, CSS, SQL. Okay. Next what we have done, we have taken different features like whether it's high level, low level, compiled, interpreted, statically and dynamically typed languages. And we have classified languages based on that. So machine code and assembly codes are low level languages. Other Java, C, C++, Python are high level languages. C, C++ is compiled language. Bash, JavaScript, all these are interpreted language. Java is both compiled and interpreted. So it's not that every language can be put into compiled and interpreted differently. There is mix and match. Java is statically typed, Python is dynamically typed. So we have classified this. So now we know how different languages look or how different languages behave. That is very important. Next, we have seen what is Java. Java is Vora, write once, run anywhere. Then we have seen brief history of Java, how James Gosling has built it, when Oracle has acquired Java, and how many versions were released in the past few years. We are currently at Java 22. Okay. Next, Java. We have seen differences between Java versus C++ and Java versus Python. This is what we have learned today. Okay. Now there are two things here. One, these are the things you can think about it now. If you have some reply, you can tell me. And this is one exercise. So first I'll go to the exercise and then we'll go through this. So today what you can do is you can just Google, find some, learn about history of Java. Okay. And in initial versions, Java has named their version. There are code names for some versions. Find about their code names. Okay. We'll discuss in tomorrow's class about these code names. Okay. Okay. Now let's think about few things. So take any example of task in your day-to-day life. You can think about this today also as well, like maybe eating. Okay. So how how will you program it with procedural programming, step-by-step instructions, or how will you use object-oriented programming, use objects to program your code? How will you do it functional programming? Just take one example and try to do it. I have shown baking a cake, right? Can anyone think about this? Next, next task is just think about this task. Till then, we'll see what is the next. Think about this. Let's say you are given a task to create a new programming language. Okay. So what will be your choices? Will you keep those programming language statically typed, that programming language, or dynamically typed? Will you keep that language compiled or interpreted? Will you keep its high or low? That means the abstractions, what abstractions you will provide. Why will you choose static versus dynamic? So why will you choose statically typed? So what this think about this will help you to do is how programmers make programming language, how you have to think when doing a program. So this is a very important exercise you have to do whenever you learn something. Think about things, how, why people would have done that, why, how it was done, why it was done. All those things, if you think, I think you will get more clarity on it and bigger picture of it. Okay. So can anyone tell any task that you think you might do it in procedural like this and object oriented may like this? Can anyone? We still have some time. So 5 minutes more, I think. Was I audible? Was there any, like, I would like also you guys to speak up since it's my first class. Was it fast? Do I need to reduce pace, or was I very slow? Was it boring? You can just speak and tell me. Was there any like thing that you cannot understand the way I speak? I would like you to give these feedback so that it's easy for me to cater to you. It might be for some people it might be difficult to understand English. It might be fast for you. It might be or it for some people it might be very slow. You might be feel bored. That's why I want to keep this interactive. Please speak up. So we still have like 4 5 minutes. Okay. What I will do is I will share these slides. Okay. What you have to do today, you will have to think about this. I will pinpoint and ask tomorrow in class what you have thought about this. It's not like homework. Homework was it's like a task you have to do. It's not like that. It's a creative thing you have to do. This is just for you to get get to know more about Java. It's not like uh, this not like a homework or something. Don't think as a homework or assignment. It's for you to learn. It's for you to realize how you have to think all those things. Okay? And these names might make there are a lot of such Android versions are named like that. Given Java version was code name. So if you know about it a bit, you will feel interested to learn more about Java. So just find out these and try to think on these questions. We will have these creative things going on in our class daily and every Friday. So this will be my class. Every Friday we will solve some practice problem based on what we learn in that week. So Monday to Thursday. And even in the class, I will show some example program or I will show demo. It will not be like I'll just present the slides like today and you will just have to learn or code yourself. No, it will not be. It will be full live demo and in like we'll practice some interview problems, even some data structures and algorithms we will see. It's not like because in interviews, even if you clear some Java rounds, you might get stuck at data structures and algorithms. So we'll see basics of that. Then you can practice yourself at home. I will give links for you to practice. I'll give links for you to read. Okay. So what I will do is share these slides. I don't know, like I think people are there in that WhatsApp group. I don't know. I'll check with uh, KSR team how they want to share it. They can share this. So you can think about this. For now, if you want, you can take screenshot of this so that even if the slides are not shared, you can have a thought about this. And we have recorded this session. So in future, you might, if you want to still like just play back and see, you might get the recording. I think I'll just connect with KSR and let you know. Okay. We will end today's lecture. We will in the tomorrow's class. First thing we'll see is these questions. We'll see some answers from you guys. So I hope we prepared for tomorrow. It's not like compulsion. It's for you to get creative. It's for you to learn and it's for your benefit. Okay. Just keep that in mind. Second, we will see tomorrow some basic components of Java, how you can set up Java in your laptop if you have laptops. Okay. And we'll see if possible, if we get time, we will see one example program tomorrow itself. Okay. So that will give you a feel of Java. Okay.